So I would like to look at 5-2 and just show y'all a few more things that you can do in the calculator. So we were on this page where we could use a formula, or we could use the appendix. And so we use the appendix on some things. We also looked at the calculator where we did second VARs, which is distribution. And we did the binomial PDF. So binomial PDF means probability distribution function. That's why it's a PDF. So we know how to use the formula and the appendix, but most likely you're going to use the calculator. So I want to make sure you know what to push and how you know how to use that. So let's look at, I'm on page 14. It is example 2. So we're going to use the calculator this time. So it says, use the calculator to find the following probabilities. Find the probability of rolling 1 5 out of 8 rolls. So find the probability of rolling exactly 1 5 out of the 8 rolls. So this is what we want, exactly 1. So X is 1. And then 8 rolls, that is your number of trials. We also need to find what P is. P is your probability of success. Well, success in this case is probability of rolling a 5. So I'm going to put success equals rolling 5, a 5. So failure is everything else. So we have a dice. What's the probability of getting a 5 on a dice, theoretically?
1 out of 6.
1 out of 6, that's it, exactly. What's the Q? Probability of not rolling a 5. Yeah. X is what we want, how many 5s we want. Exactly 1. And N, which we already wrote up here, is your number of trials. So we are going to do the calculator binomial distribution. So we're going to do, let me clear this out. I'm going to clear out my memory because I did some stuff in it earlier for another class. So what we do is we do the second VARs, which is distribution. Second VARs. And we want the binomial PDF. Push enter. Then it's going to ask you some questions. If you have an older calculator, you're actually going to do trials. So that'll be N, comma, P, comma, X. It's not going to give you a pretty menu like this if you have one of the older calculators. So you got to put trials first, probability of success, and then how many you want, X. So I'm going to fill it in here. So how many trials? 8. Probability of success, you can actually put in the fraction 1 over 6. I'm just going to put 1 slash or 1 divided by 6. X value is 1. And then it's going to paste this in there for me. And then all I have to do is push enter. So the probability of getting exactly 1 5 out of a total of 8 rolls is 0.372. We do 3 significant figures. So this equals 0.372. I think it's pretty cool how it does that. We could also use the formula. We could also use the table, but this is just a great tool to use. Let's look at the next one. The probability of no more than 2 5s out of the 8 rolls of die. So our probability isn't exactly something, so we can't say x equals something. Instead of no more than, what can x be? Less than or equal to 2. So we have the same thing. We have p, but this one we're going to have x as 0, 1, or 2, right? So p is still 1/6. We don't really need q, but I'm going to go ahead and write it. And then our x is less than or equal to 2. So in the previous lesson, I taught y'all, well, this means that x could equal 0, 1, or 2. So you'd have to find each one. So let's find what each one is. So I'm going to clear. So go back to second VARS. Go to binomial PDF. 8 trials, right? Yeah, still 8. I'm going to write that down. Probability of success is still 1 out of 6. We want to start with 0. We want to find that one first. And so see how it puts it in trials, P, and X. So the probability, I'm going to write probability that X equals 0 is 0.233, because we were doing 3 significant figures. Then we want to add to probability that X equals 1. So you know what I can actually do? Is I can go up here and just change my X value, that last number, to 1. So 0.372. And then plus probability that X equals 2. So I want to go back up and highlight that one. It's hard to tell, but it's actually, oh, I didn't change it, did I? Nope. You can change it to a 2. There we go. 0.260. So you would add those up to find out probability of no more than 2 5s. But remember how it said you don't want to round to the very end? So what I would actually want to do is I'd want to go up here and select that, bring it down. It's weird how it's not showing, like, I guess because it's really light. But it's selected. That plus the last one, 0.865. So the probability that X is no more than, so less than or equal to 2, 0.865. So if it said greater than 2 5s, then our options would be all the other ones, 3, 4, 5, 6, 7, 8. So you'd need to find each one of those, add them together. So you got to pay attention to what it's asking for. And since this is discrete, we can make a list of all of them. All right, this is another way of doing it using the list to find all possible values. I did it earlier. You don't have to do this, but I do want to show you because I was surprised by this. I didn't realize we could do this. So you go to Stat, go to Edit, and your L1 is going to be all your possible X's. So how many trials you have. So in this, we have 12 trials. So I'm going to list them all out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I'm doing is I'm creating this chart using my calculator and all the information I know. So we have that, it says enter all possible values of x in L1. Use a cursor to go on to L2. So instead of being right here, I'm going to go up. So it's on L2. This is a way that Excel does formulas and our calculator will do formulas. So what you can do is while you're on here, you can make it do this function. So we're going to do second vars and then go to binomial PDF. We're going to enter everything that we know. So our trials is 12 because they're picking 12 people in the jury. Our P is in the population, 80% Mexican American. We're going to leave the X value blank. And what it's going to do is it's going to plug in all the values from L1 for X when we leave it blank. So paste it, and it populates right here. Push enter. And then it fills in the whole chart for us, just like what we had on here. So where it starts getting numbers is actually 4. So look at 4. That's still not good enough. 5, 0, 0, 3. See how that's matching? 0, 0, 3, 3, 2. 6, 0.0155, same as this. 7, same. 8, 9, 10. See how it's all the same? So as long as you know your number of trials, your population of successes, or your probability of success, then you can create a table like this. So that is all I want to do on that.